Hello, welcome to the Bakwas channel for self-paced tutorials on Internet of Things. This presentation illustrates the installation of a solution to acquire positional data of aircraft flying near you. PiAware is the company that provides the solution called PiAware. This tutorial is limited to receiving ADSB data and forwarding these to a central publishing site. FlightAware provides the solution called PiAware. It receives ADSB data from aircraft flying in controlled airspaces. This data is then forwarded to a data center hosted by FlightAware. The data transmitted by the aircraft transponder is received at line of sight antennae. This limits the reception of data based on the surrounding terrain, the elevation of the PiAware receiver, and of course, the aircraft transmitting the data. There is a worldwide network of PiAware receivers. For some locations where the coverage is sparse, FlightAware will provide a free flight feeder unit to an interested user to improve its service. You may want to check your eligibility for the free solution at the FlightAware website. I have been using PiAware for nearly a decade. One of my PiAware computers had to be rebuilt owing to a failing micro SD card. Recovery from that event provided two thoughts. Why not get my viewers interested in acquiring meaningful real-time data? Perhaps many of you are disinterested in flying, but my tutorial is simply a cover for future tutorials on software-defined radio or SDR. I thought, why not drop a subtle hint on the potential for software-defined radio, SDR, to participate in generative artificial intelligence, AI, that is one of the vanguards in more productive use of data around us. This tutorial cannot conceivably cover any of those topics, but it is my sincere hope that as you hone your SDR experience with a solution that is almost foolproof, you will think about other uses of the underlying SDR technologies when extended to the current bandwagon called generative AI. Who knows, perhaps your tinkering may lead to a superior solution in the search for extraterrestrial intelligence, the holy grail to SETI. Automatic Dependent Surveillance Broadcast, or ADSB, transmits an aircraft's position. Any receiver can know the position of the aircraft without latency. All aircraft flying in any controlled airspace in the US must have an ADSB out transponder with very few exceptions. The ADSB out message from an aircraft relies on GPS data received by the aircraft. Please understand that there is a lag between the transmission of an ADSB out message and its corresponding publication at a site for several reasons ranging from security to infrastructure lag. This tutorial cannot cover the rules and regulations surrounding ADSB owing to the depth and scope required for such information. Also, I'm providing a graphic from the Federal Aviation Authority, FAA, on the next slide to illustrate the controlled airspaces. ADSB is required for the following conditions. Class A, all altitudes. Class B, generally from surface to 10,000 feet mean sea level, MSL, including the airspace from portions of Class Bravo that extend beyond the Mode C veil up to 10,000 feet MSL. For example, KLAX, Los Angeles International Airport. Class C, generally from the surface up to 4,000 feet MSL, including the airspace above the horizontal boundary up to 10,000 feet MSL. Class E, over the Gulf of Mexico at and above 3,000 feet MSL, within 12 nautical miles of the coastline of the United States. PiAware can be installed on several different Raspberry Pi models ranging from Raspberry Pi 3 and 4 to Raspberry Pi 0 and 02. Of course, it has been impossible to find a 02 at a retailer for nearly 2 years, but it would be the best candidate for the installation of PiAware with no other major application on the computer. All Raspberry Pi computers need an SD card to boot the operating system. If you are experienced enough, you can, or perhaps should, use a secondary storage device because the SD card will take a beating with PiAware. There are only two types of SD cards: cards that have failed and cards that will fail. Again, transferring the boot process to a storage device that has a better mean time between failure is highly recommended. There are a few publications around that cover the details, and it would be well worth the effort to do so. While the basic ADSB receiver is adequate, using a filter to remove all signals other than 1090 MHz is highly recommended before feeding the signal to the ADSB receiver. The latest generation of ProStick Plus from FlightAware does exactly that. In our demonstration, we use a separate filter. An antenna is required naturally. The SDR receiver should be as close to the antenna as practical to minimize the loss of signal strength of the analog feed. After the SDR receiver has done its job, all data is digital and line loss of signal strength becomes unimportant. As mentioned on the previous slide, the use of the band filter within the SDR dongle is preferable. FlightAware calls its version of the enhanced dongle ProStick Plus. An outdoor antenna is helpful too. Again, FlightAware has an excellent antenna at a very competitive price. A surge protector is a precautionary recommendation depending on your infrastructure power sources. The use of a waterproof enclosure for outdoor installations is recommended. I use an IP65 box for my main PiAware outdoor installation. The key steps are: install the operating system on an SD card, download and install two key pieces of software: PiAware, which sends data to FlightAware, and dump 1090, which interprets the signals. Of course, these roles are oversimplification of the tasks performed by the respective software. The PiAware website has a very good block diagram of information flow between the software packages. After completing the installation, reboot the computer. Then navigate to the PiAware website at FlightAware to claim the client identifier. Save the feeder ID, wait for a few minutes, and then view the data published by your installation to the FlightAware site. The two popular options to install the operating system on the SD card are RPi Imager from Raspberry Pi Foundation, Balena Etcher from Balena. The advantage with the RPi Imager method is that no files have to be downloaded prior to the installation task. Unfortunately, Balena, as I recall, requires the image file to be present on the computer performing the imaging. The preferred operating system release is Bullseye. You may note that it comes in several variations. Since I was using a Raspberry Pi 02W for the PiAware installation, I settled for the 64-bit desktop version. A little bit of overkill, but nevertheless not an issue from any other perspective. The 32-bit versions of the operating system will perfectly fine for PiAware installations. Before the PiAware software can be installed, the repository information must be upgraded so that the installation processes can obtain the links to the software. This activity is performed by updating the apt sources. After installing the software, the recommendation is to enable both automatic and manual updates. Then install the flight-aware version of dump 1090 if one is not installed previously. Finally, reboot the computer so that all services are started at the next bootstrap start. Download the FlightAware repository package and install it so that FlightAware software can be installed with the operating system's package manager, also known as Aptitude. The corresponding command is abbreviated to apt. Once the FlightAware repository has been defined, the references should be updated so that the subsequent install commands will ensure that the PiAware package is located correctly. During the installation of the PiAware package, additional modules will be identified and installed subject to your acknowledgement. Notice that the -y option for the install command is omitted intentionally in the example. Since updates are disabled by default, it is recommended that both auto and manual update processing be enabled. Enable both methods of update will ensure that the PiAware installation is always current. In other words, incremental refinements and security fixes, if any, are applied sooner rather than later. If any supported version of dump 1090 is not currently installed to decode the ADSB data, then the recommended version from FlightAware should be installed. Similarly, dump 978-FA should be installed as shown on the slide. Finally, reboot the computer after both installation commands complete successfully. After the reboot is complete, log on to the computer unless you have chosen automatic logon for the Raspberry Pi computer. Launch a browser and log on to the PiAware site. You will have to create an account if you have not done so previously. Then navigate to the link illustrated on the slide to claim your client credentials. Make a note of your unique feeder ID. It is strongly recommended that you save this identity securely for later reference purposes, for example, to restore or recover your installation. You can now view the data for your PiAware installation. While there are many configuration settings, this slide illustrates three common ways to examine the status of your installation. PiAware-status provides a simple summary of the PiAware operations on your computer. If dump 1090-FA is not running, then no data will be published to the FlightAware central repository. The SkyAware map is a very useful utility to view the data received and published by your installation from active aircraft. This tutorial introduced PiAware for receiving data from flying aircraft and publishing it to FlightAware. The minimum hardware requirements were examined, the software was installed, the operations were validated, some simple utilities to check on the services were illustrated. There are much simpler installation steps to get started with PiAware. These steps are illustrated profusely in the FlightAware site. If you do not want to type the installation commands manually, you may find it easier to use the pre-configured PiAware images. I hope that this very brief introduction to the capabilities of software-defined radio (SDR) will whet your appetite for other use cases. That's all, folks. Please provide feedback in any which way you can. This presentation was prepared with assistance as noted on the slide. My apologies if I have unintentionally or inadvertently omitted anyone or any resource. A very big thank you to y'all. Come back to the channel soon.